at the Department of Computer Science and Engineering at IIT Jodhpur. Sir leads the Vision, Language and Learning Group at IIT Jodhpur, which focuses on problems intersecting vision and languages. Previously, Sir worked at Indian Institute of Science, focusing on knowledge-aware computer vision. His doctoral work is on understanding text in scene images, and he was the recipient of Microsoft Research India PhD fellowship. Sir's research group has been the recipient of many grants and many awards. Let us all give a big round of applause for Sir. I request HOD ma'am to kindly felicitate Sir.
We can ask for other faculty to join also.
Yeah, sure.
People post their notes on the web. Thank you very much for coming. The big hand.
Am I audible, right?
Yes.
Okay, good afternoon everyone. So this lecture is more basics, and we will also see some, we implement some of these things, not just theory, but the point of view. Students will be attending. They can attend. So, how many of you have some knowledge, experience of neural networks?
Sir, a minute, okay, give a minute. Sir, I'll just settle them up 1 minute.
Okay.
Keep your bags there only, don't come inside. If you want to attend this session, 5 students in matter, we have a steps. Okay, 5 in here, sir is going to take you to KNN's village classification. And 5 in
Both of us from mechanical.
Okay. Right. But you all have some machine learning.
Basic idea.
Yes.
So actually here people are from different backgrounds,
Yes.
ATC, mechanical,
Right. So it's okay.
computers.
Right. So they have some. So what are things are saying? Okay. Some neural networks. Okay. All right. So we will basically try to look into this image classification problem. So this is one of the core computer vision problem. Like maybe 10 years back, this is very hard. Today may not be, because like a lot of things have happened in the last 10 years, and maybe these things are getting saturated. But yeah, God willing. So what is the task? Given an image like this, so you have an image. You want the model to identify what is there in the image. So you can classify it to that. So you may have a list of objects like maybe cat, dog. So it's more like you might have seen this Google Lens. So something, and each of the object you know what is it. So this is computer, this is pen, and so on. So it have like obviously a lot of applications if you recognize the image. So this is the image classification task. A lot of things have happened in past, and as was telling, like you might have seen this techniques like feature extraction and then classification. And these techniques were prior 2010 to 2012 actually. Nowadays they are more popular, so people used to use such methods which are more handcrafted. Okay, so these methods are more like, okay, can I capture the shape of the object, or it looks maybe some texture or something like that, right? So but then they do not scale well, like because there is a limit of doing such things. So here in this CNN, what will happen is we will try to learn the feature from the data. Right? We will not tell what to do. We will just give two things: lot of images and labels, class labels. Okay, we will tell the computer this is dog, this is cat, this is cow, and many such examples. Now the model, the computer or the model will try to learn what to look for. Given an image, what is it making cat? We are not telling anything. So that's the thing. So that is a whole line of deep learning. So where this CNN fits into. So convolutional neural network. Before that, a little bit of neural network that I started from CNN. But neural network, just to give a brief idea, what it does is it tries to mimic our brain, right? So our brain, how does it work? No one knows, right? First of all, no one knows how does it work. But people just have some studies, hypothetical things. But high level, what happens? You have some senses. We all have some senses. So what are the sensors? Our eyes, maybe ear, and maybe touch, skin, all this, right? So from the 10 sensors, we get some signal and it goes to the brain. So brain then does some processing, even if you forget about what it does, and then it gives some signal to the brain, different things like based on what are you seeing, right? So, and then you perform some action. So if it is a sad news, maybe you start crying because that's news came to the brain and brain. Similar way, people want to have a model which try to mimic neural network, human brain. So they call it neural network because neural is neuron, so they call it neural network. So now what the neural network will do? Neural network will not, will also have some sensors. So what are these sensors? Again, camera, right? The camera is one sensor, maybe the voice, microphone, whatever this is. Another sensor. So computer is getting those inputs. Now, once you have that input, but the problem here is computer are not going to work directly on input. It has to convert to some numbers to make a sense of it. So it will be always some representation of the data in terms of vector, right? It will represent each image as some dimension of some numbers, and that number will feed into the neural network. And now neural network will, as usual, it will basically again, neural network, though we are trying to mimic human brain, but again on numbers it will just do some multiplication, some addition, some non-linear operation and give some. That's how it works. So this is the typical neural network, but we'll see like that is not enough, and we will basically today I will primarily focus on CNN, but then there is a lot of fundamentals which maybe you can brush up. So this is what I was discussing is called multi-layer perceptron. What is multi-layer perceptron? Basically, it is just maybe a light image. I thought I will just start from CNN, so I don't have to explore this part. But this is actually MLP, right? So multi-layer perceptron. So it has some input layer. So this is your input. And then some hidden layer, and then some output layer, and these are connected via some weights. Everything is like connected like this, densely, some weights. And then your input. So this is the input. Now this input can be anything. It could be image, it could be text, it could be signal, like audio signal, anything. Now the thing is it will take some numbers. This is like a vector as they represent that in some way. It will do all this multiplication of these weights. These weights are what is you learn. Okay? What you learn, it will learn from the data. Initially, all the weights will be random. So first time what will happen, you will have some random weights, you will do all the multiplication, and it will be producing some output. So in the first pass, when you send the data, all the weights are random. So your output will be bad. Even if you show cat, it will say dog. It will make mistake. Then what you do, that is called a supervised learning. You give us some supervision here. You say, okay, no, it is cat. So you should correct your weights. So this loss, so this is called loss. This loss is back propagated and after back propagation these weights are adjusted. Right? So you adjust the weight and then the weight, this is called training. So this is what you do in neural network training, where you first send the training image, get the output, and whether that output is correct or not. If it is not correct, change the weights. Very high level. Right? So this is once it is the weights are changed. After a while, what will happen is these weights will be very good, and then whatever image you give, it will start saying correct. That's the high level MLP, or this is called a simple like neural network, or sometimes it is called artificial neural network. Right? This is how it is. Any question on this? Yes.
Inputs are text.
Input, if input are text, then also you have to represent that into some number. Right? Because you cannot do some multiplication. All this here happening is multiplication and addition, nothing more. Right? So this circle you are seeing is actually doing summation of Wi xi. Right? So all these xi and maybe Wij you can say. So that is what it is doing. So you have to represent everything into some number. So how people do? For example, you use some feature extractor, or in case of text, there are this word to vector. There is a technique called word to vector. So you represent each word to some vector. So in CNN, we will see that differently slightly. So here, like for example, now here, how do we process the images? Right? Our brain, does it process like A or B? A, right? Because when we see the image, we see the full picture. Not like, but the computers, right? Or neural network, this type of neural network, what it will do is, it will start from there, corner. It will read like this, all the pixels, from here to here. It will flatten it, right? And that is what goes to the neural network. But obviously, B is not the way we do, right? We want to read the image as full in parallel, because there are advantages, like you can see more images. So we want computer also to do that. So instead of, but neural network basically try to do this. See first neural network how it does. So this neural network, let's say you have an image, 32 cross 32 cross 3. Alright? This is a small image. Now why it is cross 3? RG. So you have color image, red, green, blue, so you have color. So what you do is to flatten the image, right? Flatten the image means you take the each pixels and make a vector, big vector. So this 32 into 32 into 3 will be 307. So you have a big vector which is actually like B, right? Blue like B. Okay, so you have B, and then there is these weights. These W's are these weights. You multiply those weights, and after multiplying the weight, you get one number, and then if the weight is 10 cross 3072, you will get 10 number. Why 10? Because we are interested, suppose in this example, 10 class problem. There are 10 things you want to say, maybe cat, dog, something like that. 10 such objects. So therefore this is 10. So this, what is happening actually is, for getting this one number, you are doing a dot product between each row of W and the input. And that will be one number, you will get 10 numbers. But obviously this is not good. Why it is not good? Because of that AB. Right? We are actually doing AB. So therefore this idea of convolutional neural network game, what it does is, you will start with the image as such, full, like in this case 32 cross 32 cross 3. That's the image. Now what we do is we apply a filter, okay? 5 cross 5 cross 3. And why 5 cross? Nothing is specific, right? So these are the parameters which you define. You may change to 7, you may change to 3, and it will work. Okay, it's not like.
Is it to reduce the size of?
Yeah. So it will reduce the size. Slowly it will reduce. We'll see now. So this filter are also nothing. No rocket science here. It's nothing. Very simple filter. Let me write it something like this. And feel free to ask a lot of questions because I think it's, so this filter, right? So this filter will be like, for example, it is 5 cross 5. So, yeah, 1, 2, 3, 4, 5 into 3. Each of these are some numbers. Like maybe 2, 1, 3. They're all some numbers.
Sir, can we apply this to all kinds of images, 1D, 2D, 3D?
No, so images are always 3D images in one sense, right? So images will not be 1D, but in 1D there could be text. Right? You can have a string. You can apply, but then the filter will not be square. Maybe it will be rectangle like this and so. Right? So even this filter is nothing but some weights which will be initially random. Right? So convolve the filter with the image. What is convolve here? Convolve is you have an image, you put the filter. Right? And when you put the filter in the image, what you do is you put the dot product. Right? You have a simple dot product of numbers there. And this is actually, maybe I can take one very nice quick example. What it is happening is just this, nothing more. So let's say this is your image, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say this is your small filter. Right? 1, 1, 0, 0. What will it do? You will put this here and multiply 1 with 1. That will 1 into 1. This 1 with 2. 1 into 2. This 0 with 4. 4 into 0. This 0 with 5. 5 into 0. And that becomes 1 plus 2. That is 8. So you will get an output where it will be 3 here in this place. Then this filter will be applied here. Right? Now what will the output will be? 5. Right? 2 plus 3, 5. Then it will be applied here. It will be 9. And when you apply here, 11. So this is what you get from this image to this image, and that's exactly what is happening. So you have this 5 cross 5 filter, you apply that dot product. This is dot product. So and why this is 3? Because depth is 3. So this will give you one number, right? So this will be like 75 multiplication and summation. So this will be 75 times the dot product plus 5. So this will give you one number. So this you convert like this. So for every convolution you are getting one number, and now the image size, as you were saying, will reduce, right? So now it was 32 cross 32 cross, now it became 28 cross 20. And since you have to just use one printer, the image is 28 cross 28 cross 1. Right? But if you use more printers, your size, the number of this will be more. So if, for example, if you use 2 printers, you get like this. If you use, for example, 6 printers, you get this. Now you have many filters, and all these filters are initially random. Slowly, when you train the model, they will start learning some features of the image, which are unique. Right? Maybe they might be learning some pattern which are unique to the, for example, zebra. So zebra may have some pattern. So it will, you don't have to tell the model. It will automatically, because that is the distinguishing feature. It will automatically capture those features. Some of these filters will try to capture, and if they are more, then it will say, okay, this is zebra. Maybe some other, like if there are a lot more examples. Every example has some unique features. So these filters are going to capture that. Therefore, you apply many filters, not just restrict with one, because you want to capture many things. So you get this. So this is one. This what we just did is called convolution. Convolution.
Filter means the hidden layer.
Hidden. So yeah. So filter is not hidden layer only, but yeah, you can say that. So this input layer is the image. Then one filter you apply, yeah, that can be said hidden layer, but there are more hidden layers. We will see.
So earlier this reduced size was again 28 by 28. Now it is after applying 6 filters also.
It becomes, the size is 28 cross 28, but the depth is more. Right? So each of this depth is up to you. So here we have kept 6. If you use 10 filters, you will get 10. 28 cross 28.
28, is it any logic behind?
Yeah, we will see that also in a minute. So how why it is 28.
Yeah, why it is.
So there is a number of filters how to decide this
Number of filters, yeah. So this is these are something which are which you decide, right? And there is no thumb rule. Whatever works for the data, and that is the major criticism of all this area of things. These are more empirical. Right? There is no, we have to tune, like whatever is good it works. Okay, so connecting little bit of like how do you implement this whole thing which we have discussed so far. So there is a library, you will also see it like while in whole thing in together, but just to connect. Just one line of code. So in there is a library called PyTorch, right? So it's a Python library, so you can use you can just call it, and then this is what it is saying is self.conv1 is first convolution here. It's a name. NN for neural network. Conv2D is 2D convolution. Okay. And what are these numbers? 3 is number of input channel, 10 is number of output channel, and 5 is filter size. But filter size filter will always be square in this section. Conv2D. So it will 5 cross 3. Or 5 cross 5 cross. What will be if output channels are 6, where will be changed? Only in the middle. Instead of 10, it will have 6. So this is just a one line.
if we have one filter, it doesn't capture
One is not enough, yeah. Should have more. That's okay, good. So this is from the implementation. Now what you usually do, you don't slope just by applying it once. This is why it is called deep learning. Why deep? Because you are actually applying this multiple times and the model is becoming deep. So therefore this is called deep learning because you have a very deep model, and usually these days even 100 layer models are there. So but what happens with deep layer? The deep layer you will have more filters, many more filters. In every layer there are filters. Now you have more parameters to learn, right? Because you see parameters. So these weights are the parameters which are getting learned. So for that to happen, you need more data. Because if you have less data and you have a lot of parameters, you will never able to learn optimal ones. So you have to do that. So that is, but yeah, data is there. So there here see you have seen 28 cross 28. This became 24 cross 24. And so why the site will change, we will see. So let's look into a bit more carefully how this size and all is happening. So you have an image, and now this 5 cross 5 filter is giving one number. Oh, let's take this example. You have a very small 7 cross 7 image. Right? Now your let's say 3 cross 3 filter is there, right? So first question you will have is how much that filter should move. Filter can jump 2 pixels at a time, it can jump 1 pixel at a time, like you're moving, right? So you can move more, you can move less. That is also up to you. So that is, so for example, if I move 1 pixel at a time, so this will be like this. You can see here. So starting from here, then here, then here, then here, then here. So how much time? 1 time, 2 time, 3 time, 4 time, 5 time. If you are moving 1 pixel at a time. But if you, and then similarly in this side, right? So it will move this side and then column wise also, row wise also it will move, column wise and row wise both. So you will get 5 cross 5. You will see the formula also. So you can move 2 times. This is called a strike. So if you move 2 times, what will be the size?
2.
So 1. So this will be like this, right? 1. So you move 2 times, 3 times. So you can fit 3 times. 1, 2 times. It is by 3. Stride 3, will it work? 3 pixels if you move? No. It will not fit, right? Because last you is not able to fit. That's the problem. So you cannot do anything, but then to deal with such things you actually pad the image with something. Pad. So what is really happening? This is the formula coming up. So for if your image size is n, right, and filter size is f cross f. If the image size is n cross f, filter size is f cross f, then what you get is n minus f divided by stride plus 1. N minus f divided by stride plus 1. That's a kind of formula which is coming up and which we can kind of get. So this is a padding. So what happens in padding? You pad the image so that other numbers can also fit. Pad the image with change. When you pad, the image size will change. Like how much it will change? It is changing both way, right? So if you see here, it is changing 1 pixel here, 1 pixel here, 1 pixel here, 1 pixel here. If your padding is 1 pixel, it is changing 2 times, 2 plots, both sides. But if it is more, so it is changing actually, if the padding is p pixel, 2p times it is changing. P in the top, P in the bottom. So the formula will change because the new image will be like f plus 2p minus f divided by stride plus 1. Right? So because the image size has now become n plus 2p, where p is padding size. Okay, so remember this formula because there is next I have a question. Right, so what is this? N is the number of n image size is n cross n. P is the padding, right? F cross F is the filter size. Stride, you know how much you move. 1 image. So this is the formula, and this is the question. So the question is, let's say you have an image of 32 cross 32 cross 3, and let's say you use 10 filters, each of size 5 cross 5, with stride 1, padding 2. What will be the output? And maybe you can answer. Okay. So it's not always the image size will reduce based on what the filter size is. Things may not reduce or may remain same. Okay. Another question. So another question, same setup. Now what is the number of parameters in this layer? What is number of parameters? What is parameter? Parameter is how many the filter, it depends on filter, right? So it depends on filter. What is the size of filter? That depends on that. Right? So in this case, what will be the
25 parameters.
But there is a catch here. Though we are saying 5 cross 5, right? 10 filters are there, one thing. Other thing is 5 cross 5 will not work. It has to be 5 cross 5 cross 3. Because the input size is 3 into 3. So that it will be 25 into 3, so 75. Now 75 is for one particular filter. Then there are, but then There are 10 filters, so 750 parameters, and sometimes each of these filter may have bias. So one. So for just giving an example, these parameters, right? We all know this chat GPT. How many parameters it has? Anyone has any guess?
Millions.
It has more than billion parameters, right? And these parameters are like this one, right? So this is the starting point. That is yeah. So but this is how you find, and the parameters are important because based on parameters only the model size is defined. If you have a lot of parameters, you cannot fit things into your maybe your mobile phone. Because ChatGPT you can do, but because ChatGPT is not running your mobile, right? It is running on some very sophisticated GPUs and all. So if you want to run a model, this is the important thing, number of parameters. It has to be less, but the thing is, there is always a trade-off. What do you want? Do you want performance or parameters? Alright, so now let's look into one more convolution technique, which is called 1x1 convolution. So sometime in this whole convolution thing, you want to reduce the what do you say, the depth, right? Because for example, in this example, the depth has 64, 56 cross 56 into 64. Now you want to reduce it, but you don't want to reduce the size. These are especially applicable where you want to preserve the same image, but so in this case, how do you do? So this is called 1x1 convolution. What is 1x1 convolution basically? It's just the one stripe there, right? So you are seeing this stripe. This stripe has sized 1x1x 64. Just one pixel, 64 is the width, and there is number everywhere, some weights. These are weights. You get it multiply, you will get one number. Okay? Whole number you multiply and sum it. If you multiply at every place and sum it, you get one number. If you have 32 such filters, you will get 32 numbers. Whatever filters you choose, that many numbers you will get. All this, when you do forward pass, lot of operations are happening. So this first slide is showing top one accuracy, and these are the architectures. As you can see, the accuracies are always improving with larger network. Here, x-axis is number of operations, and y-axis is performance. So ideally, number of operations should be less. Why? Yes. Because if you have more operations, obviously the time required will be less. And